So now, that was type 1 of functions that we expect to see. Now I want us to quickly move into second type of functions where we look at the domain and the range again. So domain and range. Of what functions? Before I say examples, I want to put the type. So types, this is type 2, meaning type 1 was the ordered ones. Now I look at type 2 of functions. It will be f of x is equal to h of x divided by g of x. Suppose you have a function which is a rational function where there's a numerator and a denominator. Then they ask you to find the domain. What will be a domain here? It will always be Ox on a condition that the denominator g is not equal to 0, but the variable x is a real number. This is how you present the domain, always. The only thing that we do is to reduce it, we say we can solve g. We solve for x variables. Let's see examples of this type. Find the domain of 1, f of x is equal to 1 over x minus 1. 2, f of x is equal to 3x plus 2 over 4x plus 7. Okay, let's find the domain here. So for 1, this is in that format. So our target is just g. We never talk about h for a domain. So say this is x such that x minus 1 is not equal to 0, but x is a real number. Whenever you write this, you are very much sure that I have a mark here. The only second thing you do is you solve this statement here. So you say, but x minus 1 can be 0. At which point? At x is equal to 1. So then you come and cancel here. So you say your domain is x such that x is not equal to 1, but x is any other real number. That's all. That's what we mean by type 1. Let's go to question 2. The domain will be x. So that's the first thing that I write. Once they ask for the domain in this kind of a function, my first statement is d is x such that 4x plus 7 is not equal to 0, but x is a real number. This will help me now know what to do next. Because I'm saying 4x plus 7 is not equal to 0, that's why I have work. For what value of x can this be 0? So you get that and you get it to 0. So for x, take 7 the other side, divide by 4, divide by 4. So x is not equal to negative 7 over 4. Not equal to, not equal to. Even if I don't cancel here, for as long as I remember to cancel in the final one, I say x such that x is not equal to negative 7 over 4. But x is a real number. If I do that, then I'm okay. This is type 2, where I have numerator, fraction. I mean numerator and denominator. Then they ask me for the domain of the whole function. My target is just in the denominator. provided my functions look like these two. Okay, a bit complicated one, so that we don't get used to simple things. F of x is equal to 1 over x squared plus 2x plus 1. What's the domain? We know our eyes must be that d x such that x squared plus 2x plus 1 is not equal to 0, but x is a real number. Get x squared plus 2x plus 1 is equal to 0. Solve it. The product, this is a quadratic now. So we factorize in the normal way. The product is 1. The sum is 2. So what are the factors? 1 and 1. So we have x squared plus x plus x plus 1 is equal to 0. X there, x plus 1 there, x plus 1. So that x plus 1 is common and x plus 1 remains. So this guy only at x is equal to -1. So what is our domain? Our domain is x such that x is not equal to -1, but x is any other real number. That's all. Whenever I have that type, whatever thing I have in the denominator. So as we go on, we'll do polynomials so that you can find that the denominator is to the power 3. Then you work on the polynomial, you factorize it, and get your domain. So the denominator can get complicated, but provided that I know which type it falls in, it will be easy for me to get the domain for this type. Okay, let's go type 3. Type 3, f of x is equal to the root of g of x. They want the domain. It will always be x such that g of x is greater or equal to 0 for x a real number. Okay, if I want, I can put even n there, the nth root, and then I'll give conditions that for this one, n is even. So that is if n is even, and then if n is odd, the domain will be, in fact, if n is odd, the domain will be the whole arrow. What do we mean? Let's give examples so we can see the meaning there. Excuse. So examples, find the domain. So okay, find the domain of 1 f of x is equal to the square root of x plus 3. 2 f of x is equal to the cube root of x minus 4. If I put the other one, f of x is equal to the 4th root of x minus 7. Okay, so what are we doing? For the first one, this is type 3, where our eyes are inside the root and checking the n. Now, when the square root is open like that, it means that the number outside is 2, and we call it the square root. So the domain of this, because 2 is even, the domain of this is going to be x, such that x plus 3 is greater or equal to 0, but x is a real number. What do we mean? It's x such that x is greater or equal to -3, but x is a real number. This means that we've gotten x plus 3 greater or equal to 0, taken this other side, so that we can just remain with only x, -3. This is what we take inside there to form the domain for this type. What about 2?
Oreos. It's Oreos, sir.
So 2 is Oreos. So here we'll say the domain is Oreos, because we don't care. The cube root of -1 is -1. The only change we're having is that the square root of -1 is not -1. That's why we have restrictions for the other type. What about 3? Since n is 4, which is even, we get back
x. Oh, sorry.
to x that greater or equal to 0. Okay, so it's x is greater or equal to 7, and x is error. Now these examples are getting more interesting when we combine them with inequalities. So the time we'll do inequalities, we'll get back here and get domains of the square root of a product inside, so that when we say greater or equal to 0, we are able to solve that inequality. And you must always take note that for as long as you have greater or equal to, less, greater, less or equal to, your solution will be an interval. Not where you get and say x is equal to, no. It always be greater or equal to, less, less or equal to, greater. Okay. Now I want us to do a combined one. We combine type 2 and type 3. We still want the domain. One, f of x is equal to x plus 1 over the square root of x plus 2. Remember, we have two conditions. For this type, the inside of the root must be greater or equal to 0. For this type, the denominator should never be 0. Now we have a combined one. F of x is equal to the root of x minus 3 over x plus 1. Another type. So let's see what we do. So say, okay, for the first one, the domain will be x such that the denominator is not equal to 0. But because the denominator is inside the root, there's a root in the denominator. We'll say x plus 2 should be greater than 0. we'll just remove the equal to, the greater or equal to. The equal to will be removed. Because if we allow the equal to, then we're allowing a 0, contradicting type 2. So to avoid having issues with type 2, we'll just use greater for this one. So that when we solve, it is x greater than -2, but x a real number. Sorted out. What about the other one? It will be the denominator. X plus 1 should not be equal to 0. So x should not be equal to -1. That is for the denominator. But the numerator also has an issue this time around. Because it's in the root, we must say something. So say x minus 3 should be greater or equal to 0. Now that is in the numerator, we can put the greater or equal to. This is telling us that x must be greater or equal to +3. So the domain is simply x such that x is greater or equal to 3 and x is not equal to -1, but x is a real number. It's a set of real numbers. So when we begin to combine the types, these are questions when you're alone in the exam, you say, I think for me it was hard. It's because when you're studying, you would only go for rules like this. You pick it there and end here. You don't get to think, what if they combine? Since I have this other condition, what if they combine the two conditions? Am I able to survive? But what we are doing here is that we are thinking before we meet it in the exam and then have a solution before we get there. So the day we find it there, we easily get, so okay, since I don't want the denominator to be 0, I also don't want the numerator to be undefined. So I'm going to combine, check that the whole function is defined everywhere. That's the restriction, yes?
What if we just say x is greater or equal to 3? Because what if we just say x is greater or equal to 3? Would it not be valid for this expression?
Very valid. Okay, so now I left the derivative there because if I said x greater or equal to 3, maybe I'd have confused some people to say then the other one is not important. But now you get back and overrule the other one if the greater or equal to does not include the other part. Since x must not be equal to -1, and -1 is less than 3, and x must be bigger than 3, then this is the same as just saying x is greater or equal to 3, and x is there. I'm not worried, even if x was to be -1 somewhere. It does not mean that it will be part of the domain because my domain is strictly x greater or equal to 3. So for this particular one, it has excluded the other restriction. Will it always be like this? No. We can have a situation where f of x is equal to the root of x plus 3 over x plus 1, where the numerator will be x plus 3 greater or equal to 0, implying that x is greater or equal to -3. We also have x plus 1 not equal to 0, so that x is not equal to -1. Then we'll say our domain is x such that x is greater or equal to -3, x is not equal to -1, x is a real number. Have we seen that now you can't overrule -1?
Yes, sir.
So it not always be the same, but where we're able to overrule, we overrule. Where we can't, we keep. So we can put a statement now here. What does this mean then? It means that, so we note, if the types are combined, get the intersection domain of the two domains. So if the types are combined, get the intersection domain of the two domains. What we mean here is, you've seen that we have this domain. We also have this domain. Then we intersect them to form the domain of the whole function. Here we had this domain. We also had this domain. And then you got the intersection of the two domains. Okay, so this was about the domain. Now go back and talk about the range. The interesting range here is the range of type 2 of this type. That's the range we'll start with. So we'll say the range example, find the range of f of x is equal to x minus 1, x plus 2. What was the agreement? The agreement in lecture 1 was that the range of f is the domain of f inverse. So whenever they ask us to find the range of f, what we'll do is we would let y be f, implying that y is equal to x minus 1 over x plus 2. Cross multiply, we have yx plus 2y is equal to x minus 1. What does this mean? This means that we must now solve for x. So we'll have yx minus x, meaning I take this x other side and this guy the other side, is equal to -1 minus 2y. To solve for x, we factor out this x and remain with y minus 1 is equal to -1 minus 2y. Divide by y minus 1, divide by y minus 1. So x is equal to -1 minus 2y over y minus 1. If you are solving for the inverse, in order for you to get the range, what you do is you get here and say, once I reach here, then my range is y. Just here, get the domain of this in terms of y, but write it as r, such that y is not equal to 1, but y is a real number. What we mean is y minus 1 is not equal to 0. So y is not equal to 1. That's how we solve for the range. So what we do, we look for the inverse. In the inverse, before we can switch variables, if I'm looking for the inverse because I want the range, there will be no need of me switching variables. I'll just get x in terms of y. Then the thing that I'll have with x as subject of the formula, its domain written as R will be the range of f. And that's how we get the range of f. Please don't make mistakes. If they want the range, solve for the inverse. For this type of questions, don't solve for the inverse for any function, no. For this type of functions where we are able to get the range, where we are able to get the inverse, solve for the inverse. Remember, not all functions have inverses. That's the reason why we're making that emphasis, that for this type of functions, solve for the inverse. Another one?
Excuse me, sir.
Okay.
For the range, are we getting x in place of y? Are we getting y in place of x?
We're getting y in place of x. Because the range is about what y values can you get after using x. So we get the y values and not the x.
Okay, sir.
Yes. Another example, f of x is equal to, okay, let me say f of x over -3 is equal to 4 minus x over 2x minus 1. In most cases, when you find such a question, your mind will tell you that this is strange. The mind will say you have never seen this. But we've seen this before. It just looks as this, except that the first thing we must do is first multiply throughout by -3. Okay, so we'll multiply throughout by -3 so that this guy can become f of x is equal to -3 4 minus x over 2x minus 1. That's all. At this point now, we can look for the range. How do we find the range? We need its inverse. So we let y be f of x. So we have y is equal to, I can now expand the numerator there, -12 plus 3x over 2x minus 1. Then cross multiply, so we have y 2x minus 1 is equal to -12 plus 3x. Then expand 2xy minus y is -12 plus 3x. Put the x's together, minus 3x is equal to -12 plus y. Factor out x, we get 2y minus 3 is equal to -12 plus y. Divide 2y minus 3, divide 2y minus 3. So this gets cancelled. So x is -12 plus y over 2y minus 3. What we want? We want the range. So it will be y such that 2y minus 3 is equal to 0. That is 2y is equal to 3. Divide by 2, divide by 2. So y is equal to 3 over 2. When we come here, we'll say y should not be equal to 3 over 2, but it can be any other real number. This is the range of f. That is how we obtain the range. The statement we made in lecture 1 is very important, that the domain of f inverse is the range of f. Never forget, it's the only way we have for this type of function for now to get the range. Do we have questions?
No, sir.
Okay. So let me give you an exercise.
We are submitting tomorrow.
And how do we submit, sir?
When you answer, you inbox. You inbox him
Tomorrow.
Okay, sir.
before the next class. I'll post the timetable in the night. So before the next class, this week must be done. So that if you all have challenges, then I'll start with it in the next class. So what will happen is that
Continue.
okay. So I would want all of you to respond so that even if there is one who has not understood this, if it's only one, then I'll call that one, have a session with them so that they can understand and then move on. If it's 30% of the group, then I'll attend that group. If it goes beyond 50%, then in the next class, we'll start from that exercise. We'll revise so that we can catch some concepts, and then that's when we move on. So that if you don't respond, I follow you up. Exercise. Find the domain of, so this is 1, f of x is equal to 2x squared plus 1 over x minus 7. 2, f of x is equal to the root of 3x plus 1 over 4 minus x. 2, find f of g, given f is equal to 2, 1, 3, 4, 5, 8, and g is equal to 4, 2, 7, 3, 9, 5, and 3, 5. The range of 1 f of x is x minus 1 or x plus 8. 1 over 4 f of x is equal to 7x over 2x minus 3. And the third one 2 f of x is equal to 1 over x plus is equal to 1 over x minus 1 plus 3. Okay. So this is enough. So I'll post these PDFs in the group as I post the videos also. So even if you haven't written,
Okay, sir.
see in the video.
Okay, sir.
Right.
Have a blessed night, sir.
Blessed night.